Hi, I'm Dave Stedman, founder of American Seal and Packing, which is now a part of the Marco Group. Sizing a spring seal. In order to size a spring seal correctly, here's what you need to know. Whether you're an end user or a salesperson trying to make sure you ask the right questions, this will help. No doubt the easiest way to give somebody a seal is simply looking up the pump model number to determine the seal that the factory gives out and checking it against the cross-reference. However, this will be for clean water service. If it's not clean water, you must consider the application. If it's water, oil, freon, sewage, or chemicals, the seal face is going to vary. Understanding the application will determine the appropriate seal faces and the type of rubber to be used. You don't want to give a customer a seal face or an elastomer that's going to wear out quickly. If you don't know the pump model number, or if you get a pump model number and it's not in the cross-reference, which often happens, you're going to need some critical dimensions, the basic design of the seal, and the materials of construction. U.S. Seal Manufacturing, PacSeal, which is now Flowserve, and Vulcan catalogs are all good sources for cross-reference data. Every single spring mechanical seal has three basic elements: seal faces, springs, and secondary seal elements, or in other words, O-rings, gaskets, or a rubber boot. The ID of a mechanical seal is sized to fit the shaft of the pump. The pump has a stuffing box, so you need to know the OD of the seal to know that it's going to fit inside the stuffing box of the pump. The stuffing box has a depth, so you need the height or free length of the seal to make sure that it fits inside the stuffing box when compressed 50%, which is the working length. Those three dimensions are critical: the ID, the OD, and the working length. The height or free length is the same thing, and it refers to how tall the seal is when it's standing on your desk. Every mechanical seal has two faces. One face that rotates, and the other face sits stationary. It's called a stationary seat. A stationary seat, like any other part, has dimensions. We don't need to know the ID of the seat. The shaft size defines that. What you do need to know is the OD of the seat and the height of the seat. If you take that seat and lay it flat on top of your desk, how tall is it? That is the height of the seat. The other thing you must consider with seats is what type it is. The most common seats, by far, is either the cup mount seat or an O-ring mount seat. The cup mount seat is the most common of the two. That's just a rubber cup that has a seal face that has a simple ID, OD, and height. That seal material is pressed into the cup, and then the entire cup with the seal material is pressed into the bore of the pump. The cup mount seat has an interference fit with the bore of the pump, which holds it in place and prevents it from rotating. The second most common is an O-ring mount seat, which has an O-ring groove in the middle of the OD of the seat. Its key advantage is it handles higher pressures. However, in pumps in poor condition, a cup mount seat will seal better. The most common seal face materials are carbon versus ceramic, or carbon versus Nyresist. Nyresist is a stainless steel with nickel added to reduce the amount of friction. Another combination is silicon carbide versus carbon, which is the most efficient and causes the least amount of friction when it runs. So there's less effort by the pump, which reduces the amount of power consumed, which reduces the cost for that power. Carbon versus silicon carbide is probably the best material choice for non-abrasive applications. But silicon carbide is not cheap. Silicon carbide can be used against silicon carbide in abrasive applications. Tungsten carbide is another material that can be used in abrasive applications. So that would be tungsten versus tungsten or tungsten versus silicon carbide. Bear in mind, silicon carbide will be less expensive than tungsten carbide. These two seal faces are ideal for heavy abrasive applications. However, silicon carbide is the best of the two for chemical applications. So what we want to know is what seal faces they are using in order to quote it. The other thing we need to know is what the elastomer is made of. Most likely it's nitrile, EPDM, or Viton, or in refrigeration applications, neoprene. Okay, I know I'm throwing a lot of information at you, but if you can just remember that you need to identify the materials of construction, the type of seal, and the seal dimensions, you'll be able to identify the seal. If the customer knows the dimensions but does not know the seal materials because the pump is in service and he can't pull it out and inspect it, then simply ask what the application is. Like any other application, we want to know the pressure, the temperature, and what's being pumped. As long as we know that the pressure and temperature are within the range of capability of that seal, all we really need to know is what fluid or gas is being sealed. Is it abrasive? Is it a chemical which can attack the seal faces in the elastomer? Or is it simply water? I like to ask customers if they're happy with the performance of the last seal they had in place. This is critical because often a customer just wants to put back in what they had, even though he does it every 6 weeks like they always have. You can look like a hero simply by changing the materials that are involved. Changing the elastomer or changing the seal faces will usually give you much longer life. The cost of a better seal is significantly less than the cost of having to tear a pump apart, reinstall a new seal, and get it back into production. To make things easy, we do have a webpage on usseal.com that will tell you how to size a seal correctly. I often send a link to this page so I don't have to go through all the dimensions required with the customer. They can read a step-by-step process to give us all the information we need to identify the seal. If you don't know what to recommend based on the application, Cindy or I will be available to provide you with solutions. I hope this is helpful, and we look forward to your future inquiries and to helping you expand our customer base for these products.